Denis Radin, and I'm in a bit tough situation. So in Ukraine, Russia, we have currently, and I need a bit of your help. We have currently like International Women's Day, and if I don't congratulate my spouse, she's going to be insulted. So could someone shot me somewhere here and send me a photo to my email? Cool. We are done. So yeah, email is denis.radin@gmail.com. Nice. Yeah, I bought flowers, but still absence is something you can fix only with flowers. So I work in Liberty Global. It's a big internet and TV cable provider, basically biggest one in Europe and probably the second one in the world. And we in Netherlands it's known as Ziggo. And what we do is set-top boxes. We do software for them, and it's completely JavaScript driven. So yeah, there is some C layer, but yeah, there is a browser and there is a lot of video. We are trying to use WebRTC and P2P communication to leverage our cost on maintaining infrastructure, because if we use set-top boxes of users as servers, we can save some money on our CDNs and so on. So initially talk was named as What's Beyond Isomorphic, because it's, you understand then why it's called like that, but no. As it's a Java conference, let's think, do we still need servers? And to answer this question, we probably should go a bit retrospective to understand how responsibilities were sharing and how it was changing with time between client and server. So in the beginning, there was nothing. And then God created a server and client and said, hey, server, you should distribute application to clients, and yeah, so you do everything, logic, data retrieval, and yeah, then client, please just display HTML. So it was like that in the beginning. On the second day, God created SPA, like, what's that? It's, Java developers, but still single-page applications. Single-page applications means that everything is bundled in JavaScript, so client gets JavaScript and then execute it, get some data from server. The reason for doing that, because everybody was catched by, still, it was a kind of nostalgia for Windows or the desktop application times. And let's give a whole bundle, and then somebody runs and then gets data from server. But it doesn't work in this way in web world. So the problem for that, yeah, so client become responsible for view layer, but there was a con of that, and it is a performance. So initially, Twitter was, not initially, but in 2010, Twitter became a single-page application completely. What they found that a client was waiting way longer, because when you do a single page, when you render on client, you need not only to get bundled from server, you need also parse and evaluate your JavaScript, then get data from JavaScript application, then render content, and poof, you have a few more hundreds of milliseconds, which is bad. So people started to get back to server rendering. And yeah, in order to get better performance, but everybody already had a lot of this JavaScript code to manage a view layer. So on the third day, God created isomorphism. And isomorphism means reusing JavaScript code on server, which you used on client to render your views. So it's cool. Why it's cool? Because it still gives you ability to give away HTML from server without waiting for data retrieval on client and so on. And it makes basically SPA as fast as server rendering is. And yeah, you're able to reuse your JavaScript code. Also, it means that your single-page applications got ability to be parsed by server, by search engines, and this is cool because it gives you more clients. And still, you are making SPA which doesn't mean that you wait for updates from server and UI can react instantly. So isomorphic tooling and isomorphism doing pretty well now. I'm not sure how you come on with that or not. So everybody try to make isomorphic application. Okay, do you do it with Node.js or Node.js? Okay, yeah. Because some time ago there was experiments on making this in Java, like some JavaScript machines and so on. Okay, so tooling for isomorphic is Express and React mostly. I don't think that currently somebody uses something different, and they're doing pretty well. And yeah, it's the third day, and now we are maybe entering in the first day, but who knows? Let's sum up what we know. So on the first day, UI rendering and data retrieval and app delivery was on server. So everything server is everything. The second day, single page applications, UI rendering is on client, data retrieval is on client, and app delivery is on server. And isomorphic, so client gets more and more powers. And yeah, basically, if you're observing IT landscape, so clients get more and more powers, responsibilities, and so on, but app delivery still stays on server side. Okay, fourth day. And on fourth day, God created WebRTC and said, whoa, it's the first time browser can distribute something to other browser without sending it through server. So yeah, let's do something with that. What is WebRTC? WebRTC is basically JavaScript API to establish communication between two browsers, and it works for video, audio streams, and you can also send data as a text or binary, whatever. So first day, let's try to fill the gap and deliver app from client as well. So why should we do that? What is the motivation behind that? Peer-to-peer is awesome because it's like a nice opportunity to, you know, there are a lot of countries who tries to ban websites. And for example, decentralized websites could be not banned. But I'm joking. Really, I was not going to talk about that. It's like politics. Let's keep us technical guys. Let's keep us on this side. So you can reduce distances. For example, you are currently in Sweden, and app server is in USA. So usually, if you want to get application from the server in USA, you'll go to New York and then to Washington, and then you get from server, and it's few thousand kilometers trip. But if you do P2P, once it got to Sweden, it will be there, and you'll get it from your neighbor. It's cool. Other option is to deliver through corporative network. Delivering through corporative network is cool because by research, the average speed of internet is about 10 MB in Europe, and average speed of corporative networks is 1 GB. So yeah, it's basically 100 times faster. And once your application gets there into a corporative network, it could be distributed in this network with this optic fiber with really high speed. So yeah, it sounds good, and also it sounds challenging. It may sound like it needs a lot of some new infrastructure or whatever, and could be a lot of programming, but it's not. Let's consider how can we do this and how can we enable client to distribute applications via WebRTC. There are a few options to do that. I'll tell about one I'm trying to evangelize, but we'll also consider other one. So, orange square is your application code. So it's markup, JavaScript, CSS, and so on. To make it P2P distributable, this application should have some code to distribute itself. So once we seed application to client, to first client, we add a thing called viral addition. It's basically 50 kilobytes code, which if it's going to be requested from other browser, it will give application code and virtual addition. So it's a package first client gets. The second client, a browser essentially gets infected by apps. So once one browser is infected, one browser gets this virtual addition. The rest will get application from it. It depends on determination of should it be seeded from server, or because in some cases it's still faster to get from server. Okay, but yeah, it's like infection of browsers. Second one gets just scene client. So scene client is also 50 kilobytes sync, which says, okay, I'm there, I don't have application code, please give me the closest peer and give me application from there. So then the scene client goes P2P and gets virtual addition and application code. Okay, now we see that the second browser got infected, and it could proceed as long as you want. So yeah, then you have 1,000 browsers with your application, and who knows, maybe you don't need server. But it's not like that. Yeah, there is a diagram. I just explained it without all this tough stuff, so we can skip it. Yeah, so it's viral JavaScript, and basically JavaScript application distributes from browser. Yeah, clients got more rights. Okay, why did we do that? Let's try to make some mess in order to be sure that it makes some sense and it doesn't make us way slower or whatever. This is the part which you really should be patent. I mean, yeah, just it's really boring because we'll just try to sum some numbers and we have some application size and virtual addition size. You know what virtual addition is, and scene client size, and internet speed, and internal company network speed. So I got this example of internal network because it's hard to, as example, because about geography, it's hard to calculate because of different delays, depends on equipment and so on. But here we have pretty strict numbers. We can, yeah, here is explanation what every, how our formals are going to look like, equations. Yeah, so basically we consider that virtual addition and scene clients are distributed via internet, and application itself is going to be distributed via internal networks. So yeah, we calculate speed based on that. Let's consider that application size is 1 MB and virtual addition is 50 kilobytes and scene client is 50 kilobytes. Then we have a difference in speed. This one is a really crucial, and that's the reason why I picked this example, because there is a research on average speed of internet, and it's pretty constant in Europe. So we can not just guess, but yeah, it's based on some data. And yeah, optic fiber, 1 GB. What we have here, the compression is just, yeah, 1 second. And for P2P is going to be like many times less. It's really a big improvement. And 1,600% improvement. And yeah, let's go further. Okay, let's imagine that your application size is 3 MB. And I really know that if I work further on that, I can leverage the size of, reduce the size of virtual addition and scene client to 10 kilobytes. It's possible. So yeah, there are a lot of exceeding code and some libraries there, so it could be really skinny. Then we see then bigger our application is, then more beneficial is to share is through P2P. That's basically the reason why we're trying to serve video content with P2P, because yeah, it's basically could be served from neighbor and it's cooler. every time you do P2P communication, you should consider that establishing a connection is slow, but transferring that data is probably going to be fast because your seed, your peer you're getting information from is going to be near you. So here, after this reducing sizes of viral addition and SIM client, we got 7,500% improvement. There is no focus, it's not a trick, it's just a simple math, and it could work like that, but no, it's not realistic. So yeah, like, let's have a bit of disappointment. It was too sweet, to be honest. Not every user is P2P. So someone still needs to get this application from server. Let's consider that in average you have your application distributed to corporative networks which have 5 users. So one gets from your server, the rest gets from this seed inside of network. So in this case, we'll have win about 6,000%, still amazingly sweet. And it's not realistic. And the reason for that is, yeah, handshake takes a lot. And then, yeah, in an ideal world, 2 browsers can say, hi, it's me, and they'll say, oh, it's you, I like to speak with you, and they can establish connection, but in real world, where we live, it's not like that, it works. And it works because of nets. So there is no real physical address, mostly for 2 nodes, and they can't reach each other directly, or otherwise they need a route to each other. And yeah, it's basically couldn't be done without help from server. Yes, so WebRTC needs signaling server. What it do? It helps 2 clients say the possible route from each to other, as bypassing nets, and all this procedure, it's pretty complicated. So all the stuff about signaling is really a thing which makes WebRTC hard stuff to code. There are some libraries to polyfill that and make it easier. But it's hard to code, and it's hard to establish connection. It takes a lot of time. In good case, in ideal case, it will take additional 4 round time trips. So in average, it's like, good case, 400 milliseconds for a connection. So let's consider this in our calculation, and now we get 400% improvement. And it's in a pretty good case because establishing connection, finding a route can take longer. It's not only about round-time trips. So at least we see that there is a possibility not to spoil that much our performance, and it's possible. So yeah, it's like, it's not realistic, it's a good case, but it's close to be. So alternative, I was talking before, web torrents. Why not web torrents for application delivery? Torrents are good for delivering videos, big pieces of content, because for torrent, you also have delivery through browser, but you still need your nodes to coordinate them. It's a torrent nodes, and also you need to establish connection not only with WebRTC, but with torrent protocol. So it's going to be way slower. I would say it's going to take a few seconds just to establish connection, and then there's a benefit of web torrents that you can get your application from many users in parallel. And yeah, okay, here's the demo time. You were patent enough, you got all this mess, so okay, let's try demo. Demo is going to be taste best of all if you have a laptop. If you have a laptop, it's good. If you have Android, it could work. If you have iPhone, it will not work. Do someone have a laptop, or you have a laptop? And I have a laptop. Cool. It's good. We have at least 2 nodes here.
I have to log in with Facebook.
Yeah. It's nothing to do with your credentials. There are very simple permissions to get your first name and avatar, and then you are going to be displayed as a, okay, I'll run it, and let's see how it goes. It's no. Pow, 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 pow. So we have some people here. So have you succeeded to?
Yeah, the one.
Oh,
Now.
we got one more. So any mighty Android users try to join? It's Facebook doesn't give us avatars anymore, so we have some. Oops, sorry. Yeah, look how fine is it. It's so cool, but there are not that many people here. Have you do you still waiting for someone to join? Or okay, we are done. So sorry for that, but yeah, not that many people. Yeah, the nice thing that if you ever used Express.js, you can establish this P2P staff URL communication with few lines of code. Basically, you install viral.js via npm, and you register your viral container as middleware. Then it adds viral addition, and all the magic happens. So, answering question, do we still need a server? If we have WebRTC, yes. We still need a server for signaling. And there are some possibilities connected with P2P. Then bigger your content, then beneficial is sitting it via WebRTC. There is a big shift of making the whole AT landscape not server-centric, but having some kind of equal rights between server and client, and that's what we see for the last few years. But still, server is there, and we can't work it around. So thank you. That's basically it. If you have some questions, it's really slicky. Yes?
Yeah, how do you handle security?
Yeah, security. Yeah, the slide is there because it's easy. So it's a topic when it's easy to destroy me with questions, where as this kitty destroys our planet. And security. Let's talk about particular concerns. So what are you concerned about?
It seems pretty easy. I mean, just to, since you're sharing client to client, somebody could just poison the code and just pass on any modified.
Oh, you still ask server for give me someone, because once client gets this viral addition, it registers itself on server side. So I'm sure that currently you can invent a hack, probably, and try to join a server and try to trick someone and get some, and do some XSS or something like that. Yeah, it's something which could be improved, but in a simple case, you can't just inject. You need to really trick server and then go from there. So you can't just drop some content because initially it's being requested, hey, what peer do you have near me? So yeah, still we have request to server, and it decides which peer is going to.
Yeah, but the client only asks the server for a peer, right? But
Yeah.
There's no kind of validation of what the peer actually
Yeah.
is.
Yeah, if you substitute, if there is a peer, but if you unload it from memory, the connection will disappear. So it's a WebSocket connection currently. So if you drop a script which was originally sent, it doesn't have connection to server anymore. So if you substitute peer's script, so it's not connected to server. So server can suggest. Yeah.
What I think you mean is that currently there's no solution for it, but it would be possible that a server might send back some checksum or whatever, so you can verify, but it's not currently there yet.
Yeah.
As far as
So,
okay, and I have a question about persistence, but I think you answered that one because it's only as long as the page is still there.
yeah, it's true.
Connected. But how about because a lot of people are getting like this unknown or limited internet these days, or if they have vastly limited upload speeds, because that's usually the problem with peer-to-peer. Like, okay, you have great download speeds, but not so great upload speeds. And
Yeah.
how do you deal with clients that don't? I mean, is there an option for them to disable this peering
So-
for themselves? I guess it's currently not very easy. They have to go in options, disabling WebRTC or something like that, and so on. Because I can see that this would work quite well in a corporate environment. There you can basically ignore the security part. You can say, yeah, whatever. It's on the internet. It's safe. As we do everything else on the internet, everything is safe there, right?
Yeah.
And as well as having that. But when you have like, well, if say Google starts doing this, will probably cause a lot of massive use of user bandwidth, and probably lead to people saying, hey, this WebRTC thing sounds nice, not for me.
Yeah, I agree.
How is that like going to be handled? Is there like someone thinking about, okay, you need some standards for this? How much traffic can we use? Are we going to cap it? Are we going to?
No, there is no solution for that. So let me put more details on compatibility and support for browsers currently we have. It's supported for Firefox, Chrome. Apple just hired engineers for implemented it in Safari. And it's not there on a desktop Safari. You can't use it. There is a polyfill for that using Flash. And there is support on Android starting from 4.4. There is no support on iOS. I'm not sure how it's handled on Android, but as you see, so for iOS users, it's not the case at all, because mostly we will talk, if considering your question, it's more about mobile users, because at home you have not fiber optic, but it's good channel. So yeah, but for Android, it's a good question, and I'd like to make some research on that. But my feeling is that there is no way to set it up. So, but it's really a hole in the system, because you can harm users, and yeah, it's true. That's probably the reason why Apple still don't have in Safari and iOS, because of these considerations. Yes?
How do you make a difference between a page that is static and dynamic? So if I'm requesting a resource that is actually dynamic, I need to go to the server. I cannot get that from up here. So how do they know?
You mean, for example, because there are some different cases. For example, which resource?
For instance, if I go to facebook.com, what it shows me is going to be different to what it shows you. So then if I go to facebook.com, I want to make sure that I go to the server and get stuff from there. Because if I go to you as a peer, I'm going to get your Facebook.
Yeah. Now, currently it gets JavaScript bundle, so you get all this JavaScript code, and there is intent to make rendering like in an isomorphic way. So if you think about that, it's still same JavaScript, which could be same React, and you can render on peer. So you can render your image. So there is no difference with isomorphic approach. You can still see HTML specified for particular user, but yeah, there are also downsides, because you need to get data for this particular user and render HTML for him. So yeah, there are some problems with that. Yes?
And how do you handle load balancing? Let's say you just have 5 peers and one of them keeps on getting all the incoming connections and gets swamped. Is there some built-in mechanism for that?
Balancing. So currently there is a ability to make a hook for user. Balancing currently made just by IP. So if you are close by IP tables, you get a package. But there is possibility to make a hook which determines if you have some corporative policy or you know something more about structure of your network, you can hook and give socket and give peer, which works good for you. So only this way, because you need to know a lot of specificity on how it works, what kind of peers is that, and yeah. So there is no solution like let's get Java load balancing or Nginx or whatever and use there. Oh, for first user, yeah, for sure it could be Nginx, but then it depends. I mean, it could be improved. Definitely you can consider on server who is now sitting and block these users from sit twice in parallel, but it's still not there. Well, it's a nice point. Yes?
We use this as a sort of like start up a few, well, not fake clients, but sort of like some seed clients in a few countries, and do use them as initial seed clients there. I mean, as an intermediate way of, well, getting a few seed clients going and distributing the load there.
Yeah.
And that would be, I think, quite easy to do.
Yeah. It's basically the whole stuff you can do with that is to build kind of self-maintainable CDN. Once you get it into some location, it's there. And yeah. And also, you should remember that it works only for big applications. So if your application is 100 kilobytes, it doesn't make any sense. I saw some questions over there.
Actually, it was the thing that you just mentioned, the CDN. So the idea behind it is something like to have the CDN among the users. So not something like the existing services, but actually we should all share the same JavaScript or CSS file in the application.
Yeah. So basically, once some laptop or whatever gets some browser tab. So until it's not closed, it's going to be there. So also a possibility is, and it's not in browser still, but there is big buzz in WebRTC community about, have you heard about service workers? Service workers is ability, it's like a proxy, JavaScript proxy, built in browser. So once you got some requests to, so you can put some piece of JavaScript into background and make it intercept all requests. And like if you got some image from, if you are looking for some image from internet, you can intercept this request and process it. So there is some same intent to make it available for WebRTC. If it's done, it's possible to have WebRTC have this sync in background without tab being open. So it's going to be a big improvement, but still not there. Okay, no questions. Thank you. And, thank you for photo.